Welcome to the Rachel Varga podcast. I'm your host, Rachel Varga, double board certified aesthetic nurse specialist since 2011 with over 20,000 rejuvenation procedures performed. I'm an international clinical trainer for other physicians and nurses as well, celebrity skin expert, having been featured on some of the world's top proactive aging podcasts, and much, much more. Learn more at rachelvarga.ca and enjoy today's episode. Welcome everyone to today's episode on the Rachel Varga podcast. Thrilled to have you joining me here today. We're going to talk all about, well, is sugar really that bad for us? Is it okay? Are we sweet enough? How much sugar should we be consuming? What does sugar do to our skin that could be inadvertently aging us when we're trying to sometimes indulge a little bit and have a little sweet? Is it worth it, or is moderation the key? So in today's episode on the Rachel Varga podcast, we are going to discuss aging in general and how sugar consumption and blood sugar balancing impacts your skin aging, and also some of the changes that we experience as we age, especially for the female listeners when they hit menopause and the switches that change in the body. We're going to be talking about some research with actually medical scientists here on the show. And thank you everyone for joining me here on the show. Please subscribe, like, share this episode with a friend or family member. Many blessings to you and your loved ones. Also, just a reminder that I live stream all of my interviews here on Facebook and YouTube. So be sure to subscribe and hit that bell notification. But all of the super, super juicy audio only solo episodes are always only exclusively on the podcast, which you can find at rachelvarga.ca/blog, and be sure to subscribe on your favorite podcasting platforms. So let me tell you a little bit about today's guest. We have Dr. Richard Johnson, MD. He's a practicing physician and has been a medical scientist for over 25 years. He is internationally recognized for his seminal work on the role of sugar and its component fructose in obesity and diabetes. His work has also suggested a fundamental role for uric acid, which actually is in some skincare and which is generated during fructose metabolism in the metabolic syndrome. Dr. Johnson is a prolific scientist with research that has been funded by the National Institute of Health since the 1990s. He has published over 700 papers. I'm on 5, so I got a little bit of catching up to do with this gentleman. Lectured in over 45 countries, and his work is highly cited. He previously authored The Sugar Fix with Timothy Gower in 2008, Rodale, and The Fat Switch in 2012, Mercola.com, Dr. M, as I like to call him. He is currently a professor in medicine at the University of Colorado in Denver. He lives in Aurora, Colorado, which I love to get to Colorado one of these days, with his wife, 2 children, and 2 miniature golden doodles. There's always something special with dog and animal lovers. Welcome, Dr. Rick Johnson, to the show. How are you today?
Wonderful. It's great to be on your show, Rachel. And I'm looking forward to learning about beauty myself.
That's great. About 25% of the audience here on the show are the gents. So it's nice to talk about the differences between the two, because there are different aging processes that women experience. There's actually a paper on this from 2018 that women's faces change shape 3 times faster than men's between the ages of 50 to 60. Thank you, menopause. So we're also going to be talking about some of the switches that you've identified in your clinical research that goes off in relation to sugar and metabolism. So how did you get into this field?
Well, so I'm a clinician as well. So I'm a physician. I see patients every day, but I also am a professor who does a lot of research, and I love research. I'm very curious. And I started off many, many years ago trying to figure out what's the cause of high blood pressure. And it's known that high blood pressure is commonly associated with kidney disease. And so I started looking at the idea that maybe there was a problem with the kidney, with its ability to excrete salt as a mechanism to drive high blood pressure. And that it took me to the idea that the kidney might actually be injured in a way where it couldn't excrete salt. And that took me to a substance called uric acid. And we found that uric acid could do that, and that uric acid could raise blood pressure. And then we said, well, there's a lot of people with high uric acid. And, how are we getting a high uric acid? And it turns out that one of the easiest ways to get a high uric acid is by eating sugar. And sugar, is basically table sugar is called sucrose, but there's two sugars in it. One of them is glucose and one is fructose. And it's the fructose component that generates uric acid. And when we started studying that, because I keep following my nose, whatever is really interesting. When we started studying fructose as a cause of hypertension, we found that fructose also was really capable of activating, a biologic process where animals would suddenly become fat and insulin resistant and old. and so what we did was we started studying the mechanism. We found that uric acid was involved in it. And then I started studying what caused obesity in the wild. When animals would hibernate and so forth, they would suddenly get fat. And we began to realize that this fructose could be used as a switch, that animals eating fructose could use it as a trigger to gaining weight. Later on, we found out that this pathway is involved in aging. And so it's really been a very exciting tour, beginning as a kidney doctor, and now I'm studying sugar and metabolism. But it's been a process over about 30 years, so it's been a long time.
That's great. You learn so much in your clinical experience. Like there's a paper I just finished writing yesterday. It's an algorithm for skin rejuvenation, and to start from lowest to all the two most invasive, not starting with the most invasive first, but working on the skin health and setting the stage. And you really only learn these things through clinical observation and taking notes from those clients of yours that are seemingly aging backwards or aging better than the rest?
Absolutely.
So what are the common trends that you've observed in some of your most vibrant and radiant clients that seem to be aging slower that you work with?
Well, one thing I've noticed is that people who drink a lot of water, is that coffee too, though? Are you drinking coffee or water?
Yeah, this is a little bit of bulletproof coffee with, some butter, MCT oil, a little bit of honey, even though I'm sweet enough, y'all.
There
But a
you
little
go.
bit of honey. So I don't follow really any diet super strict. I just follow the foods that are good for me that I've identified through different biohacking testing and analyses.
Well, anyway, I sounds like a pretty good plan. I noticed that a lot of people who drink water a lot, tend to be skinny and healthy in appearance. And but it was commonly viewed as a myth that drinking water is protective. But interestingly, in our research, we actually identified how water can block aging processes. And so I don't know if you want me to go into that story or not. It's sort of an
Yeah,
interesting
that
story.
sounds really neat. And I'm a huge proponent of always making sure that your water's purified, your air is purified in your home, and that you're not accessing or allowing your body to be exposed to a lot of junk light like LED. And I actually just made a free download. You guys can all pick it up right now at rachelvarga.ca/slow aging. And it's 9 tips for healthy skin and some biohacking tips in there for slowing your aging. So I'd love to hear your take on water.
Okay, so I'm going to begin a little bit with the story of how we discovered this switch, and then it will take me into why water is protective. So it's going to be a little circuitous, but it begins like this. When we discovered, along with other people, of course, that if we gave sugar to animals, that they started to become obese. And that's not a big surprise, right? Everyone has been aware that sugar can cause obesity. But what we found was that there was an actual biologic process that sugar treated that was independent of calories. And so sugar contains this glucose and fructose. And what we found was that when you gave fructose to animals, that it caused a drop in the energy in the cells. So normally when you eat a nutrient, you make energy, right? We eat calories and we use it to generate the energy to let us do what we want to do. And we call that energy ATP. And so that's how I'm talking, walking, exercising, everything I do, thinking is all burning this energy. And basically we eat food, we breathe oxygen, all to kind of help generate this energy that we use day to day. Now, there's two types of energy though, really. There's the active energy we're using, which is the ATP. And if we have extra energy, we can store the energy, and we store that as fat. And when an animal gets fat and then hibernates, when it's hibernating, it burns its own fat to produce the energy it needs. So in other words, that fat is like a stored energy. And when you burn it, you produce ATP. So ATP really has two sources. It can be in fat where it's stored and it's produced when you burn the fat, or it can be made in real time. And normally when an animal eats in the wild, it will, use it to make energy. And it always has a little fat to protect it in case there's like no food around. But for the most part, it will regulate its weight perfectly. And it will, if it eats more one day, it eats less the next. If it exercises more one day, it'll either eat more to keep up with it or, but basically it will stay in the perfect weight. And actually people, a lot of us, when we were young, it was like very difficult to gain weight for many people. And not for everyone, but a lot of people, they could say, it doesn't matter. I can eat anything. I'm just, and that's because initially humans also, we tend to regulate our weight well initially as in our early life. But when you eat fructose, what it does is the ATP normally is produced in a place called the mitochondria. And this is these little energy factories that are in our cells. And so they're pouring out the ATP. But what fructose does is it kind of stuns the mitochondria, and it reduces the ATP that's produced. And when it reduces the ATP that's produced, the energy that's coming in, instead of being used to make ATP, is used to store fat. So the energy balance is still there. There's the same number of calories are going in, but more of them are being put into fat as stored energy than into real energy or ATP. So what happens is our ATP levels fall. And when that happens, that's like an alarm signal to the animal that it should be hungry. Hey, my energy levels are low. I better go out and get more food and so forth. And also they get thirsty and they want more water. And so they start foraging for food, and they disengage their control of appetite, where they now will keep eating. They don't know when they're full. And it's actually due to it disrupts the signaling in the brain that tells us when we're full. So this switch is like a magnificent thing that when it goes on, it helps an animal suddenly go from regulating its weight really well to suddenly gaining weight, and it starts to get fat and it becomes insulin resistant. And it does all these things that we call the metabolic syndrome, and that we think is bad. And it is bad for us, but for an animal, it's helping it prepare for when there's no food around. And even insulin resistance is a good thing for these guys, because what happens is that it means that there's less glucose being taken up in the muscle, because the muscle requires insulin to take up the glucose. So the glucose, which is our main fuel in the blood, is not being taken up by the muscle. So there's more of it to go to the brain. And when there's not enough food around, you want to be insulin resistant so that you get enough glucose for your brain, because if the brain's not working, baby, you're not working. So what we discovered was that fructose activated this biologic switch. And fructose is in the wild, animals are eating fruit, and we know fruit is healthy, right? But these animals aren't eating 2 or 3 fruits, or like when we say fruit's healthy, what we really mean is it's healthy if we eat 1 or 2 fruits with each meal, perhaps, or maybe, but if you eat a huge amount of fruit, you start getting a lot of fructose, which is the sugar in fruit. And that's how animals trigger fat switch. If you put a dollop, you told me you put a dollop of honey in your coffee. A tiny bit of honey is not going to do it. But if you start eating honey on everything you're eating, you're putting honey here and honey there, you're going to get a lot of fructose, because honey, the sweetness in honey is from fructose as well. So it's all about portions, right? So if you eat one natural fruit, it's got fiber, it's got vitamin C, it's got these things that kind of counter the fructose. And so natural fruits turn out to be healthy. But fruit juice, where you mix a lot of fruit together and now you've got a lot of sugar, that will trigger this switch.
You might as well just drink pop if you're drinking juice.
Yes,
Stop drinking juice, everybody.
I did a study with apple juice where I gave apple juice to people, and I could show that it triggered the switch. It triggered this biologic switch where it was going to make them hungry and all those things. And interestingly, if you want a trick, if you drink, we did this study where you drink it fast or drink it slow. And because the way this works, it's the concentration of fructose. When the cells see the fructose, then they drop the energy. But if a huge amount of fructose gets there, the energy drops even further. And the more it drops, the more severe the switch. So it's kind of like a dimmer or something. You can turn it on big time, or you can turn it on a little. And so if you drink a liter of apple juice, boy, you're really activating the switch, especially if you drink it fast, because it floods the system, right? Whereas if you drank the apple juice over a 2-day period and you were eating other things to kind of slow the absorption and so forth, like some fiber or something, then it would probably just be a calorie. But fructose does not just act like a calorie, because if the concentration's high, it triggers that switch. And if it's really low, then it's just a calorie. But if you get a high concentration, the switch is activated, and boom, you get hungry, thirsty, and so forth. So originally, when we discovered this, that there was an actual switch, we said, well, how's it working? And it turns out that it was that uric acid I told you about. So everybody has uric acid. Uric acid was thought to be a waste product. And it's sort of a waste product of ATP. When ATP is burned, you produce uric acid. And also, like when you break down DNA, it's like it's breakdown of nuclear material or RNA and so forth. It's basically a high nitrogen containing substance. And, birds, when they poop it's the guano. It's that white stuff that you see on the walls of the cliffs where the swallows are dropping their poop. That's actually very high in uric acid. But anyway, we make uric acid too. And of course, we don't poop it as guano, but we excrete it through our kidneys and in the urine. And that's how we get rid of it. But it can build up. And if you eat a lot of foods that have a lot of sugar in it, a lot of fructose, you can get a high uric acid. You can also get a high uric acid from eating foods that are high in purines, like beer. Beer has this brewer's yeast, and alcohol also breaks down a little bit to make uric acid. So alcohol and especially beer can produce uric acid. But one of our major sources is from fructose. And when that uric acid is made, it actually is what dampens the mitochondria to produce less ATP. So it's actually involved in kind of reducing the energy in the cell. And that makes you hungry and activates all these switches. So the way it does it is it actually causes a thing called oxidative stress. And oxidative stress is part of the aging process. And what it does is it causes oxidative stress right where you don't want it, which is in our energy factories that make our energy. And when the fructose acts on it, it decreases the energy just transiently, and that makes you hungry and you eat more, and then eventually you get back to normal. But if you keep eating a lot of sugar, which has fructose in it, over a long time, those mitochondria get beat up, and suddenly you have less mitochondria because the recurrent oxidative stress takes a toll. And that is associated with aging. And that's part of the aging process, is that we start losing these energy factors, and then we get tired more. We get weaker. We start getting muscle wasting. We get wrinkles. We start aging. And, so what we thought of, was could this pathway be involved in aging? And we had animals where we genetically could block this pathway, where they couldn't metabolize fructose, and they were protected from aging. When you get older, animals, including humans, will get aging changes in our kidneys. For example, our kidney function will start to decrease. Just as we age, once you turn 50, your kidneys aren't working as well. And no one really understood what caused that aging process. But when we blocked this pathway, the kidneys stayed normal. The animals did not get high blood pressure with aging. They stayed lean. They stayed, normal blood pressure, no response to salt. I mean, they really were protected. And we're doing more studies to look at how this blocks aging. It was known a long time ago that like fruit flies will eat fruit, but they eat small amounts of fruit, and they eat it with a little, they eat the fruit with the fruit juice, but they also get other things from the fruit. But if you give a fruit fly refined sugar, like liquid sugar, they like it too. And they're getting fructose as well, but they're getting it highly concentrated. And it actually makes them die younger. They die younger. It accelerates aging in the fruit fly. And they develop kidney failure. The little flies actually develop kidney failure. You probably didn't know that flies actually have something that's sort of equivalent to a kidney. And it's from uric acid. It was shown to be due to the uric acid that they were making from the sugar.
That's so fascinating. So when you're mentioning sugar, you're mentioning grazing. Actually, just last week, the same day, I saw a mama bear and a baby bear. It was very
How
cute.
cool.
Very cool. From, a safe distance, of course. Thankfully, not on the trail I was just on, that I came across a wild strawberry patch where surely they're going to be going. And I'm definitely going to be nibbling on those strawberries as well. Wild strawberries next to the ocean. This is nothing short of magical. I'm clearly living my best life over here, finding wild strawberry patches and the bears. But yes, this grazing type of approach is something that my husband does as a pro athlete. He eats very small amounts throughout the day. And as an athlete, he's putting his body through a lot of oxidative stress and inflammation through, the whole getting your mitochondria to work to make that ATP. And then, of course, you get metabolic byproducts from that. So we did some testing, and I came out 9 years younger biologically versus chronologically, and he was about 2 years younger. So clearly some of the biohacking stuff I'm doing to support my mitochondria are really helping. The blood sugar thing is the next deep dive I want to go through. Yeah. And so this is something funny that came up for me while you were speaking. So if we're hungry and we're needing some energy, say that afternoon slump, you just need a snack, right? Don't reach for the sugary snack. What should we reach for instead?
Yes. So actually, those wild strawberries that you described would be a good one. So let's talk about that again. So, wow. So when a bear goes after fruit, it will eat huge numbers. Like there was one study where they ate something like 10,000 berries in a 24-hour. They measured it in the scat.
Yeah, there's scat.
That's a job I don't want. But
it's all bears. When I'm on the trail, I know there's lots of bears around by how much scat I see. And it's just everywhere in the summer. And it's literally all berry seeds, like pounds of it.
But with berries, especially berries, they're not as rich in fructose, but they have a lot of really good things in them. Speaking of things like flavonols, like strawberries, I think have one called fisetin, and blueberries, are really good. So they have these flavonols, and we actually found that some of these flavonols could block the effects of the switch, could block fructose, and so things like wild strawberries and blueberries and things like that that are rich in these flavonols and vitamin C, they actually neutralize the fructose, and there's not much fructose in there. So you're actually doing well. Now, if you ate a huge number of them, you might you might activate the switch. One of the things that
probably feel like I'd want to take a nap. Those poor fruit
exactly,
flies.
the energy, the ATP levels dropping.
Yeah.
Yeah. Well, you know, yeah. So one of the interesting things about fruit is that when the fruit we like tends to be a little bit tart and not super mushy or ripe, like some of the animals will actually like it when it's fallen off the tree and it's kind of mushy. And the reason the animals like that is because as a fruit ripens, the sugar content goes up, so it gets sweeter. You noticed that, I'm sure. But also the vitamin C and the flavonols and things like that go down, so that it's more like a fructose load. It's getting closer to being like a soft drink if you eat a whole bunch of them. But the fruits we tend to like, which are a little bit more tart, they tend to be vitamin C rich and flavonol rich and have less fructose, and we don't eat as much. So anyway, so what I recommend is if you're, trying to, make it through the afternoon without hitting the chips and the potatoes, chips and stuff like that, eat a natural fruit because it's got with whole fiber and all that stuff. Just eat one, and and that should really help. And especially things like berries, kiwi has very high vitamin C, low sugar, but it can be an orange. Orange doesn't have that much sugar, believe it or not. It's about 6 grams of fructose or so. But that's what I would do. And then, so when we first did these studies, we were focused on sugar as the bad guy, and high fructose corn syrup is its equal. Actually, high fructose corn syrup is a little bit worse when we compared the two. It was even more potent at activating the switch, even when we paired it up for exactly the same amount of fructose. So anyway, so high fructose corn syrup and sugar were our main guys. And we said, oh my God, this is it. If we could just block that, we can have a huge effect. And then we had this terrible discovery, Rachel. It was really disappointing. We had this discovery that the body can make fructose. It was known, but no one thought that the fructose made by the body could be responsible for obesity or responsible for aging. But what we found was that it can be. And the way you make fructose is you make it from glucose. And the way you get your glucose is from those potatoes, the French fries and the chips and all these, like the high glycemic carbs. And so when you're eating high glycemic carbs, even though it's starch, which consists of glucose, in the body, it's being converted. A lot of it is being converted to fructose. And we know that you can make at least the equivalent of a can of soda from a high glycemic meal. So if you're really eating a lot of potatoes and rice, that actually activates this process too. And then comes the water story. So when we were looking at how the body made fructose, it actually requires an enzyme to be turned on. And enzymes are those things that basically drive a chemical reaction. And the reaction to convert glucose to fructose is a chemical reaction. So you have to convert and change the glucose over to fructose. And to do that, it's a chemical reaction. And that enzyme normally is present in very low levels in our body. So normally we don't convert a lot of glucose to fructose. But guess what turns it on? Sugar turns it on. And another thing that can turn it on, high glycemic carbs can turn it on. When the glucose in your blood goes up, that turns it on. But another thing that can turn on the enzyme is dehydration, and especially very, very mild dehydrations. And the easiest way to do that is to eat salt. And, salt, a lot of people love salt. But if you eat a lot of salty food, especially with carbs like French fries, that salt will help convert the French fries to sugar, to fructose in your body. So the salt activates the enzyme, and then the carbs get converted to fructose. So if you're on a low carb diet, you can eat a high salty food, and you don't have the carbs to convert. So the salt kind of just doesn't have as much effect. But if you're eating high salty foods with carbs, like salting your potato and things like that, now you're going to start converting that glucose to fructose. So when we learned that salt might be a mechanism for driving obesity, we started looking at it in people, and by God, it was scary, Rachel. Most people who are overweight or obese are eating a lot of salt, and salt intake is just really pretty high in people who are obese. And the signs of dehydration, salt makes you thirsty, right? And that actually makes the salt concentration go up in your blood, and that's called dehydration. And people who are overweight or obese are somewhere between 2 and 12 times more likely to be dehydrated. So it turns out that it's a real common thing, and that dehydration, that salt, adds to the sugar. So when you buy that popcorn that's got the salt and sugar mixed in it, you're getting the double whammy. The sugar's bad, but the salt is actually further activating this whole process to make you fat and old, because that, remember, the way the switch is working is it's causing oxidative stress of the mitochondria. And that's the hallmark of aging, is to lose those mitochondria over time. And that's what this does.
That's just crazy. So here I am making myself some healthy ramen with, yam noodles that have no carbs. And
Beautiful.
What else would I put in there? I'd put in some yams and some other vegetables. But then I have all this salt from my miso and soy sauce. So here I am trying to have like a healthy meal with some carbs. And then there's, a fair amount of sodium in it. Little do I know that the mechanisms that are happening in my body is actually converting it to glucose, fructose.
Yes. So
wow.
It is having an effect. So one of the things we did was we started looking at this, and we gave salt to animals. And when you give sugar to animals, they get fat within a month or two. It actually takes a month. When you start giving sugar to a laboratory rat, it will actually try to regulate its weight for like that first month, and it won't gain weight, even though it loves the sugar. It takes about a month for it to lose its ability to regulate its weight. And at that point, then it starts to really gain weight. But with salt, it takes a lot longer. So you give an animal salty food, it will go 3 months. It's eating more, but it just seems to burn more. I mean, it just keeps in check. And then suddenly, all of a sudden, everything goes to pot, and the animal starts getting fat and diabetic, and everything accelerates, hypertension. And if you block the switch, you block all the effects. They don't even get hypertensive. So the switch is actually, the production of fructose is actually even the reason salt drives blood pressure up. So then, this is where water comes in. So we realized that the salt was working by increasing the concentration of salt in the blood, and that was activating this enzyme to convert glucose to fructose. But what if we could eat the salt, but could prevent the salt concentration from going up in the blood? In other words, if you took salt and at the same time you took water, you could dilute the effects of the salt, so that even though you're eating the salt, you wouldn't be activating the switch, because the switch requires the salt concentration to go up and for you to get thirsty. In other words, if you ate salt and drank water so you didn't feel thirsty, could that block the switch? And so what we did is we first did it in animals, and we found that we could turn off the switch by just giving water. And it didn't even matter if it was from salt or sugar. So you give an animal sugar and you make them drink a lot of water, it could block some of those enzymes and prevent them from getting fat. So it was incredible. But we also looked at it in people. So what we did is we gave people soup. And, you know, you can mix a lot of salt in like creamy soup, and you can't tell how much
You
salt.
really have to be careful for with those tinned and canned and prepared soups. They're like a
Oh,
salt
yeah.
trap.
Oh, I know. And I love those creamy soups. But you can, you know, they can hide a lot of salt in there. And so we gave a soup with a lot of salt to people. And when we did, we could show that the salt concentration goes up in the blood. That activates the enzyme. And then we could show signs of dehydration developing. And we could show this big spike in blood pressure that occurred right away. And we could tell that the switch had been activated. We gave the same salty soup, the same amount, to other people. And we gave them, one group, we gave a small amount of water, and another group, we gave a large amount of water. And we could totally block the effects of the soup to activate the switch by increasing the water content to prevent, if we could prevent the salt concentration going up in the blood, we could prevent it. So what it means is that water, we can, you know, is a good thing, because a lot of people are eating salty foods. A lot of people are eating, you know, those salted chips or whatever you're eating. What do you got there? And so when you're eating salted food, it's activating the switch, and you can block it by drinking water. And that is why drinking water is so good, because it helps keep you from activating the switch. And we later went on and actually showed that a hormone that's turned on by dehydration, it's called vasopressin, actually is responsible for how sugar causes obesity. It works with the uric acid. And if you suppress that vasopressin hormone level with drinking water, you can block the development of obesity in these animals. So sugar and salt are both working through this mechanism that is it's kind of activated by dehydration, but it's activated by salt. And it's driving fructose production in the body. So it's not just the fructose we're eating, but it's also fructose that we're making. You know,
My mind, you have no idea how much my mind is just blown, because every time I have sushi and I have soy sauce with it, I'm just crazy thirsty. Javi and I had our
yes,
anniversary the other day, went out for some sushi, and, you know, go to a movie. I'm like, I'm so thirsty. And it's like your
you,
body clues in that it
yeah,
needs more water.
your body's activating the switch. So here's a great rule. This is just to help everybody. I mean, this is simple, and it will definitely have a benefit. Drink 6 to 8 glasses of water a day, at least 8 ounces. You may need to drink more if you're really active, but drink 6 to 8 glasses of water a day, and drink a glass of water completely at the beginning of each meal. And what that does is it reduces the concentration of salt in your blood, so that if you eat something salty, it's going to protect you. So drink a glass of water first. Drink one when you get up in the morning, when you have breakfast, when you have lunch, when you have dinner, maybe in between. Try to get like 6 to 8, maybe even 10 glasses of water a day. But here's one thing, please listen to me about this. There are people who can who drink too much water. So if you're drinking like 20 glasses of water, you can actually get into trouble. The body may have trouble if you drink that much, and you can have seizures and so forth. So keep to what my recommendation is. And then the second thing is, if you're a marathon runner, there's some people who run marathons where they will suddenly hold on to water very quickly, easily. And there have been deaths. There was a death in the Boston Marathon about 3 years ago where someone fell over after drinking too much water during the run. So what they say is, if you're doing endurance exercise, like, you're on a treadmill for an hour and a half, 2 hours, drink to thirst while you're doing it. Maybe, the next day, go back to drinking 6 to 8 glasses of water a day. But if you're doing a marathon run or doing something really long, just drink to thirst for endurance exercise. And also, if you've got a heart failure or things like that, talk to your doctor before you drink too much water. Or if you have surgery, post-surgery is another situation where you have to be careful. But for most of us, drinking water is simple, it's real, it's beneficial, We proved it. It isn't a myth. Those people running around with all the bottles of water and they're skinny, they're skinny for a reason. The water's helping them. Exercise is helping them too.
That's fascinating. So thank you so much for sharing all of that. And as y'all know, this is not medical advice, even though we have a clinical medical doctor in the house here. This is educational information only. One
Right.
weird thing I do before bed is I literally drink a liter of water before going to bed. And for whatever reason, I feel like it just helps my brain detox. I sleep better. But that's not for everybody, especially if you have a bit of a smaller bladder.
Yeah. Yeah. If I drink a liter of water before I go to bed, I would be up in about 30 minutes. But
I don't know what it is. I always sleep better.
Good for you. Good for you. I always wake up thirsty though. So I think
I'm thirsty right now.
Yeah, I probably needed to do more. So
maybe I'll drink some waterfall water today and I'll think of you for sure.
So I'm going to tell you another little story about aging that's sort of interesting. And that is, so as you know, there's all this data that caloric restriction can increase lifespan. And so people like the people in Okinawa who were just eating about 2/3 what everybody else was eating, they tend to live longer. And I think our research is sort of identifying a little bit of the way that works. So remember that with aging, we lose our energy factories. And so as we get older, our mitochondria aren't working as well. And then that makes us gain weight and we age because we can't repair things as well. And at the same time, we're also, having this continued oxidative stress that's causing aging. But the main oxidative stress to those mitochondria is when it's trying to store fat. So when you're eating excess of food and you're storing fat because you've activated the switch, that's what's driving the aging process. And the oxidative stress to those mitochondria are causing them to, over time to decrease in number. So when you do caloric restriction, you are actually reducing the oxidative stress to the mitochondria, and so you live longer. But if you actually didn't eat the foods that activate the switch, like high glycemic foods and a lot of sugar and stuff, if you could reduce your intake of that, because you can't stop that, but you could reduce it, you're going to get the same benefit. So that it turns out that when we block the switch, or if what happens is these factors that are associated with aging longer and with longevity and with youth, those factors stay high in the body, and we can measure them. There's these things called sirtuins, for example, and things like that. And so we can show that the aging process is really linked with this fructose pathway. So I believe that sugar and soft drinks and fruit juices, high glycemic foods, and things like beer all activate this process that can cause aging. So how do we block it? Well, we talked about one was drinking a lot of water, because it actually blocks this process. Obviously, avoiding sugary beverages, not putting sugar in your coffee. Green tea actually stimulates mitochondria.
I love matcha tea.
Yeah.
Yeah, this is actually my matcha cup. Sometimes I'll have matcha or coffee. I kind of mix it up a little bit, but I always feel better on the days I have matcha.
I'm going to follow your lead there. I like green tea, and coffee is actually healthy. I'm drinking coffee.
You just have to make sure it's organic. It's
Right.
been mold tested. You're making it with filtered water. You're not boiling your water in like a plastic kettle and getting plastic microplastics that way. And also, if you are having green tea, make sure it's always organic, because the first time that the coffee or the tea gets hot water poured over it, if it's not organic, you're literally drinking pesticides. So
thank you for telling me that.
And also,
oh my God,
go for loose leaf.
Does Starbucks have the good coffee? I hope. Anyway, don't
I
you
feel
don't have to.
like I feel terrible after Starbucks coffee. I get like jittery and I don't feel
Wow.
very good. So here, I love everything you've shared. I've just gotten so much out of hosting this episode with you here on the Rachel Varga podcast. I've learned so much. I'd love to have you back on the show. So get your wheels turning about content that, come back with us and hang out with us again and share with us some more insights to slow aging. But I'm going to drink more water. I'm going to eat less salt. I am going to
That's
eat
right.
wild berries.
Yes. Vitamin C is good too. Taking vitamin C is good.
Oh yeah, I do all sorts of
And
wonderful
things like
protocols.
omega-3, like in salmon and
Yeah, I eat a
all
ton of
that's
salmon.
good. Yeah, that's good stuff too.
I
Yeah, you
actually
should. The
I
living
eat a
a
lot of
bad
raw salmon
probiotic.
actually.
Ooh.
So yeah, antioxidants, omegas,
Yep.
collagen. Making sure you have your trace vitamins, minerals. If you want any specific recommendations for products for skin and all of that, send me an email info@rachelvarga.ca and I will get you set up. Be sure to pick up a copy of Dr. Johnson's book, Nature Wants Us to Be Fat. I don't think nature's the only thing that wants us to be fat and sick. I think that there's some other people out there that want us to continue to buy some more of their products
The food
as well.
industry.
Don't get me started on that. Big Cosmo is just as bad as big food. The more I dive into the sourcing of ingredients and hormone disruption and all that craziness, it's just as bad.
Processed foods are filled with salt and sugar. So
Yeah. So learn more about Dr. Johnson and work with him at www.drjohnson.com. His direct link is in the show notes. And can you please share exactly how people can work with you?
So my website is drrichardjohnson.com. And you can also, that's a very good site to try to reach me through. Also, you can reach me through the Ben Bella, which is the publisher for Nature Wants Us to Be Fat. And my book is available on all, Amazon, Barnes and Noble, Books A Million, all these different avenues, so venues. Good.
Wonderful. Thanks for being on the show. And
Thank you.
I can't wait for the questions after this episode from my clients and requests for next episodes. And if you can also book a time to be back on the show in the next little while and just share some more insights with us, because I love how you present. I love your knowledge. I can tell that you are just a rock star healer yourself. Your clients are so lucky to work with you. Thank you.
Oh, thank you. And you are a rock star too, for sure. Anyway, thanks.